Okay, in these notes, we're going to talk about average rate of change. So here's the heading that you're going to put on your paper, page, your name, the date, and the title. I'll give you a few seconds to write that down, and you can always pause the video if it's going too quick. The first thing we're going to do is come up with the definition for average rate of change, and I abbreviated it so we wouldn't have to write that out forever. So that's just average rate of change. So average rate of change, if you've done slope before, it pretty much means the same thing, but it's just over a tiny interval. So can you write measures the steepness, or slope, of a function based on a specific interval. This is the longest part we'll have to write. Based on a specific interval of the domain. And what that means is your x's. So if you want to put x's in parentheses. So the definition might seem a little bit more difficult than it looks. All you're doing is doing the slope function, just doing the slope formula to find the average rate of change. So can you write to find the average rate of change and abbreviate to find the average rate of change, make a table. Make a table. So this is what you're going to do. You're going to make a table and then you're going to find the change in y over the change in x's. Can you write that for me? These little triangles mean change. So I'm going to point to that and write change. So that's the change in y's, change in x's. And all you are doing is rise over run. I'm sure you've heard of that phrase before, rise over run. So I will show you how to do that 3 different ways, with a graph, with an equation, and with a table. So we're going to start off by using graphs. So can you write graphs and underline that for me? So what we're going to do is we're going to draw this little graph here, and we're going to make a sketch just like we did before, but I'm going to use the real graph that I have. So if you could make this little graph for me. So we're going to make an X and Y axis that looks like this. X and Y. And we're going to make it look very similar to this. So we're going to have it curve up like this and over. And there's going to be 4 specific dots. So if you could darken those for me. And I'm going to give you those points. So this graph is what we're going to be looking at. So we're going to be using this graph to find our points. So we're going to find the average rate of change. So can you put find average rate of change? We're going to abbreviate. For the intervals. And we're going to do this twice just so you get a feel of it. We might actually do it 3 times. So the first way, can you write 0 is less than or equal to x is less than or equal to 4. If you saw the previous lesson on domain and range, your x would be your domain. So we're talking about the numbers from 0 to 4. So this is what you do. This is kind of neat to find the average rate of change from 0 to 4. That means we want to know what the slope is between 0 and 4 on the x-axis. All we have to do is just make a table. So you're going to make an x and y axis or x and y table. And all we need in the table are these x values, 0 and 4. You don't need the numbers in between it. So 0 and 4. To find the slope, we need to find the point that it represents. So 0, what is in the graph? Well, that is 0, 1 if you can't see it. So I'm going to put a 1 there. 4, what is on this curve? Well, that would be 4, 7. This is how you find the average rate of change. All you have to do is find the differences and divide. So what do I mean by that? The x's are going up by 4. 0 to 4 is going up by 4. So I put a 4 there. On the y's, to go from 1 to 7, you're going up by 6. So I'm putting a 6. Your average rate of change, I'm just dividing the numbers. I do y over x. It's the change in y's over the change in x's. So it's 6 over 4. If I want to reduce that, I can leave it as 3 over 2, or I can change it to 1.5. So either answer would be acceptable. Let's try another one. I ran out of room, so I'm going to go to the back, but I'm going to bring this little graph with me so we can see it for reference. So we're going to do another example. This is example 2. And I'll put 3 to the side. We might as well do a third one. So I'm going to move this down for you so you can see it, and I'll put this over here. So for the second one, we're going to do 4 is less than or equal to x is less than or equal to 7. So what I want to know is what is the steepness from 4 to 7? That would be between these 2 points. So we're going to make a table, x and y, and we're going to put 4 and 7 in our table. To find the slope, we first have to find the points that it represents. So this point right here was 4, 7, so the y is the 7 value. This point here is your 7, 10, so the 10 goes here. To find the average rate of change, we're going to do the differences, which means how far does it go up or down. So to go from 4 to 7, it goes up by 3. To go from 7 to 10, it goes up by 3. To find the slope, we just do y over x, so 3 over 3, that gives you 1. So your steepness is 1. So it's less steep than the one that we had previously. And here's our previous slope, 1.5. One more. Can you write 7 is less than or equal to x is less than or equal to 13? So to find the average rate of change from these two x's, we're going to make a table, x and y. The reason why we have so many examples in these notes, I want to make sure you understand this concept. So we're going to put 7 and 13 for our x value. To find the point that it represents, we just find the point on the graph. So 7, 10 is on our graph, so we're going to put a 10 next to the 7. 13 is next. This is 13. This is 15. So I'm going to put 15 here. To find the average rate of change, I'm going to do the differences. To go from 7 to 13, that goes up 6. To go from 10 to 15, that goes 5. To find the rate of change, we just do 5 over 6, not 6 over 5. It's always y over x change, and we can't reduce that. All right, notice, I want to put a little note here. If you have the same number more than one, so if we had the same slope, that means we would have a line. So can you put a little comment for me? Linear functions that equals a constant rate of change. What that means is it's the same slope, same rate of change. So constant rate of change. Constant rate of change. Okay, so we've talked about graphs. Now we're going to talk about equations. I'm saving the easiest for last. So if we want to find the average rate of change of equations, we just make a table. So I'm going to give you a function. So can you write down f of x equals 2x squared plus 1? Can you write for me find the average rate of change? Oops, I'm sorry. Here we go. Find the average rate of change for the intervals. And I'm going to give you 2 examples. And if you want to try one on your own, you can. And then you can always pause and try the other one. So the first interval, we're going to do -2 is less than or equal to x is less than or equal to 3. The second example, we're going to find the average rate of change over the interval 1 is less than or equal to x is less than or equal to 5. So this is what we do. Like previously in the what I mentioned before, to find the average rate of change, we're going to make a table. So to find the average rate of change, these are our x's, so -2 to 3. Asking just for a second, do you know how we would find the y value that goes with these x's? Well, remember, y is the same as f of x. So all we would have to do is plug in 2 times x squared plus 1. We'd have to change these x's. So since I have a calculator, I'm going to do that for us. And I'll put my calculator on. So I'm going to redo this. So instead of 2 times x squared, it's going to be 2 times negative 2 squared. And then plus 1. That value, if you can see it, that says 9, so I'm putting 9 in my table. Now I'm going to do the same thing for the 3, so I'm going to back up here. Oops, let me clear this, might as well clear it out and start over again. So I'm going to do 2 times 3 squared. And then we're going to do plus 1. And if you can see my calculator, we get 19. So now that we have our table, we can find our rate of change. We do the differences. Negative 2 to positive 3 goes up 5. 9 to 19 goes up 10. To find the average rate of change, I divide the 10 or the y by the x, so that's 10 over 5. And that gives us 2. So the average rate of change is 2. If you want to pause the video and do this one, you can. We're going to find the average rate of change from 1 to 5. So and y go here. 1 and 5 go underneath. To find the average rate of change, I need to find the y's that go with it, so I'm going to plug these in. So I'm going to change my x to 1, so it's 2 times 1 squared plus 1. My calculator says 3. If I change that 1 to 5, let me back up and get rid of that 5, or 1. My calculator gives me 51. Now I can find the average rate of change. From 1 to 5, it goes up 4. From 3 to 51, it goes up 48. So the average rate of change would be 48 over 4. That's 16. So this tells you that in this equation, it is steepest, because the higher number, this is the higher number, it is steeper from 1 to 5 than negative 2 to 3, just like if we had a graph. One more part is our table. We're saving the easiest for last. So I'm running out of room because I'm writing so big. So let me move on to the back. Last part we're going to end with would be tables. So I'm going to have us find the average rate of change in a table. So here we have a table. We're going to have, let's see, 8 going across and 2 going down. So here's my table. And I'm going to have 8 spaces. So 8 columns, 2 rows. So this top row is going to represent x's and the bottom row is going to represent my f of x's. Very similar to what we did the other day with functions. So my x values going across are going to be negative 5, negative 2, negative 1, 3, 6, 8, and 15. The next part, our y's, our f of x's would be 4, negative 3, negative 7, 0, 5, 4, and 2. So to find the average rate of change, we're going to make a table. So I'm going to have 3 questions here. So 1, 2, and then 3. So we're going to find the average rate of change from negative 5 is less than or equal to x is less than or equal to negative 1. I'll give you the next one in case you're wanting to do that one next. Negative 2 is less than or equal to x is less than or equal to 6. And the last question is going to say, is the table linear? Is the table linear? So what we're going to do is find the average rate of change of these numbers like we did previously in equations and graphs by making a table. And if the table is linear, that means we're going to have the same rate of change for both of these. So I'm going to make my table. This is the easiest because we don't have to figure anything out or look anything up. We just look right at the table. So to find the average rate of change from negative 5 to negative 1, I have x, y at the top. I'm going to put my negative 5 and my negative 1 in my x column. To figure out the y's that go with it, that's the same as f of x, so I just look at the table. Negative 5 is with 4, so I'm going to put 4 here. Negative 1 is with negative 7, so I'm going to put a negative 7 here. Now I just find the average rate of change. To go from negative 5 to negative 1, that goes up 4. You can always use a calculator if you're not sure. To go from 4 to -7, you're going down 11, so I'm going to put -11. If I divide that to make it rise over run, to make it a slope, it's -11/4. I can't reduce it. I could change it to a decimal, but I might as well leave it. The next one, I need to find the average rate of change from -2 to 6. So x and y go at the top, or you can have x and f of x. My -2 and 6 are my x's, so I'm putting that in the x column. And now I go to the table. -2 is paired with -3, so that goes in the y. 6 is paired with 5, so I'm putting that in the y column. Average rate of change. To go from -2 to 6, you're going up 8. To go from -3 to +5, you're going up 8 again. If we divide, we get 8/8, and that reduces to 1. So your average rate of change in that section of the table is 1. So the question says, is this table linear? Well, they do not match, so that means it's not the same. So it is not linear. So the answer is no. So these are your notes. Please don't forget to upload a picture of it in Canvas in this assignment.